Would you like to learn how electronics work? TinkerCAD, the website that I showed 3D design, actually has a circuit section, and it teaches you all about how electronics work. In today's video, I'm going to show you the beginnings of learning about circuits in TinkerCAD, and in future videos, I'll walk you through some of the other lessons. So stick around. So the first step is to get logged into TinkerCAD. Just go to tinkercad.com and you can either sign up or log in with your Google account. Okay, once you've done that, and I covered that in other videos, once you've done that, you want to go to Learn. So you'll just click Learn and you'll get to this screen. Now, we went through this in another lesson, all the starters and a few of these lessons. What I need you to do is click right here and click on circuits. Now there's a code block ones as well, but let's do circuits today. And today I'm going to be doing the starter lessons. So these are all the starter lessons. If I say show all lessons, it's just these 4. So I will go back to this and we'll get started. So start simulating. All right, so whenever you open up one of these lessons, the directions are always going to be on the left-hand side. So it says, let's learn how to test a circuit design with the simulator. So we click next. If you can't see this on your Chromebook, you need to zoom out. The way you could zoom out, you would click over here and press minus, or you could hold down the control button and use your scroll wheel on your mouse. Let me full screen this. We click next. It says click on the Start Simulator button located at the right of the toolbar. So if we look at on the right side of the toolbar, it says Start Simulation. So we just click it. All right, so we saw that this LED lit up. Now that's not extremely exciting, I get it, but it's teaching us the basics so then we can actually do things. So then we click next. It says, congratulations, you simulated your first circuit. Use the simulator to test your circuit design at any time. If you want to simulate other pre-made designs, check out the starter circuits, which you can find by clicking the plus components. Plus components. All right. Button and then selecting the starters tab. All right. Continue on to the next lesson to learn how to edit component properties in circuits. So we just click done. So that just showed us how to start it. Then we can say continue. And it brings us on to the next lesson, the starter lesson. This is just teaching us the basics of how this is set up. If you haven't seen my video on Arduinos, go ahead and watch that. You can come back and check this out. But it says, let's learn how to edit components in your circuit. This is a real thing you can buy, and this is how we use it. I made a video on Arduinos, and this you can actually simulate an Arduino without having to buy one. It's nice having one in your hands, though, and actually physically making it. But this is a good simulator. So it says click next. In this work plane, you'll find 3 blue LEDs. Now, LEDs are these things. They're called light emitting diodes, and they let out light. I'm sure you've probably heard of LEDs before. 3 resistors, that's these things. All right, resistors, 3 resistors, and an Arduino. Don't worry about the Arduino for now. We'll get to that soon. We're going to go ahead and edit the LEDs so that we have a traffic light. All right. It says click on the topmost LED. You'll see an inspector appear that lets you edit the properties of the component. Change the color of the LED to red. So they want us to change this to red. So if I click on it, this comes up, and then I can click on the drop down and change it to red. Now, obviously in real life, you just grab a red LED. Click and change the middle LED to yellow. So click it, change it to yellow. And you could rename these, but leave it the same for now. Just because this is a simulator, sometimes renaming things messes up the lessons. And then click and change the bottom LED to green. So this is just like a normal stoplight, right? Red, yellow, green. Continue to the next step. Let's check that our traffic light works as expected. Click on the Start Simulation button on the top right to test out your traffic light. So let's see what happens. It's green, it turns to yellow, and then red. All right, now they did some programming in here, which they're going to teach you in a little bit. If you just hooked this up and did no programming, nothing necessarily, let me see. So ground, yeah, nothing would happen, okay? Nothing would happen if you didn't program it. So If you connected these, you could connect them differently so they'd light up, but not like this. That involves some programming. Your traffic light should be blinking. You can also change the color of your wires. Try selecting different components in this design and see what properties you can change. Now, the color of the wire really doesn't matter, right? That's just for us and keeping things organized. The color, it's all copper wire. This looks almost like steel wire, or aluminum. It's all wire. So the color, that's just the insulator on the outside, and it helps us to better organize what we're looking at. All right. When someone wires your house, they keep the colors the right way because otherwise they get confused and wire the house wrong, and your electrical could cause a fire, could cause issues. Things could be wired backwards, stuff like that. What happens to the brightness of the LEDs when you edit the resistance of the resistor? So these are called resistors. Excuse me. And you'll see this red one runs to the red light. And if I change the resistor, what that does is there's electricity flowing through here. Think of it as like a hose with water going through it, right? A resistor sort of slows down that flow. And so if we change the resistance and we allow more of a flow, let's change this to less of a resistance. So there's twice the amount of flow. You'll notice that the light is now brighter. Now I wonder if I can change these. Let's see. Okay, it won't let me change it. I'll show you in a little bit how we can actually set these up so it'll be constantly on. But we can make this a lot brighter. And actually in real life, if we change one to resistance of a certain amount, it would actually burn out the LED. In this case, I don't think they're going to be doing that. We'll let it run more too. Yeah, they don't let it burn out. What happens to the brightness of the LED when you edit the resistance? The resistor helps reduce current in the circuit so that the LED does not exceed its maximum rated current. So if it gets too much electricity in real life, it would burn out. So we got rid of that resistor, it would burn out. In later tutorials, you'll learn how to program an Arduino to make your designs interactive. If you want to take a peek at the code that's running your traffic light, click the code editor button in the toolbar. Now this is where I was talking about this had to be programmed. So if we look at the code, some people might think this is confusing. I want to describe it to you. It's not that bad. They're saying it says the red LED is connected to pin 0 of the Arduino. So they're saying something that we're calling LED red, which would stand for that red LED, is going to be on pin 0. See the 0? They're saying the red one is there. Then we're calling whatever's connected to number 1, we're going to call it LED yellow. And whatever's connected to number 2, right, the number 2, is LED green. Then void setup. This runs every single time that you turn on your Arduino. You'll notice on Blockly coding like code.org or Scratch, you'll always have this thing that happens right when you turn it on. This runs one time when you turn it on. So it says pin mode. So these we call pins. This is pin 0, pin 1, pin 2. And they're saying pin mode of LED red, so this one, is an output, meaning it's going to put out electricity rather than receive electricity. And we'll talk about why it would want to receive electricity sometime. They're setting all 3 of those pins to say electricity is going out. That is what output is. Then they're saying do this loop. So continue running this forever. It says digital write LED red low. That means have this one off. LED yellow low. Have this one off. So no electricity running through those. And then it says LED green high. So run electricity through the green. Don't run electricity through the yellow or red. Wait 2 seconds and then change the code. So then instead of having the LED green high, it's going to have the yellow high and the green low. What that means is there's going to be electricity flowing to the yellow, but not to the green or red. Then, now maybe you can see why the colors of the insulators are important to be able to organize your thoughts. Then it says, wait 1 second, and then we can then turn on the red one. Now what we can do, we could change this code, all right? Oh, I can't change the code on this. I'll show you sometime. We can also change our Arduinos, but they're not allowing it right now. All right. Continue on to the next lesson. Wonderful. So hopefully that gives you a sort of understanding of the code. This stuff after these 2 backslashes, I believe they're called, those are just notes. So those don't have anything to do with the coding. This is to help people that are reading the code and editing the code, hacking the code, to better understand what the code does. So it says set up all the LEDs as output, turn the green LED on and the other one's off. So that sort of describes what was going on. This says there's a delay. I was looking at the wrong section actually. If I change this, which I can't, won't let me, that would change the delay. It's saying 2 seconds. This is 2,000 milliseconds, which is equal to 2 seconds. Let me click done, and we'll move on to the next one. A lot of that code is already provided to you. You don't actually have to type it up when you're working with Arduino. It's provided online, and you can copy and paste it into your program. So if you don't know how to computer program yet, that's okay. Just start reading through that programming to see if you can make sense out of it, okay? And those notes really help. Let's learn how to wire components together to create electrical connections. So if we're just looking here, we have a 9-volt battery. It has 2 connections. There's a positive connection, it says positive, and negative. We normally do black as negative, red as positive. And then we have these buttons here, push buttons. This is a lot like what's inside the Xbox controllers or the PlayStation controllers. When you push the button down, that's actually inside your controller. These are resistors, a bunch of different resistors. We've got wires laying all over the place. This is a microchip of some kind. This is a piezoelectric speaker, and then there's a capacitor. We'll talk about those components in a little bit. So let me click next. In the editor, you'll see a 9-volt battery on the left. We need to add wires to connect the battery to our circuit. Hover over the red terminal of the 9-volt battery until you see the positive label. Click to begin adding the wire. So if I click, now I can add a wire. It says hover over the breadboard, which is this white thing with all the holes in it. Hover over the breadboard and click on the hole next to the plus symbol to complete the wire. So if we look, there's a plus here and there's a plus here. And I'm not sure which one they really want, but I'm going to go here because I see more wires connected here. This speaker is connected there. So we'll see how it goes. What that does is you'll see this green line going all the way across it. The way the breadboard works is when I connect something up here, that actually makes all of this, anything connected to those holes, connect to this wire. Same with if I connect it here. You'll notice the lines show up horizontally. If we're looking at these, they actually connect vertically. And we'll get to that in a minute. This is a way so we don't have to be soldering a bunch of stuff together. It's a really nice way of organizing our prototypes, learning about electronics without having to actually make something that's more permanent and hard to take apart, and using a soldering iron, because this makes it a lot easier to fix your problems. Then you can solder it later on another board. Click on the wire and change the color to red in the inspector. So we click on it and we change it to red. The biggest reason why we change it to red is because this is positive, and red, keeping those colors, red as positive, really, really organizes things. You'll notice that means that this is positive, this is positive, this is positive, and this one is going to be negative. Click continue. Wonderful. Wire the negative side. So hover over the black terminal of the 9-volt battery. You'll see that. Click on it. It says hover over it and click on the hole next to the minus symbol to complete that one. So now do that, and we're going to change this one to black to keep things organized. Now we know this is all negative and anything connected to it is also negative. And you'll notice this wire runs from here all the way down to here, making this all negative, this entire row negative, and this positive runs from this wire to this one, making this entire row positive. So we can connect to either one of these to get electricity. So because they're all connected, now we have a positive rail here and a negative rail here, as well as here and here. We can connect to either of those for power. Click next. Then it says, now that we've powered our circuit, let's test it out with the simulator. Click the Start Simulator button. I don't know if you can hear that noise, but you can see it. It did pop up, but then it stopped. So let me do that again. Made a little bit of a noise. Ensure that your computer's sound is not muted, so you may not be able to hear it, I'm not sure. On the breadboard, you will see 8 buttons. While the simulator is running, clicking on the button will trigger each switch. Try clicking on each of the buttons to hear what happens. Now I'll turn mine up. Maybe it'll come up on the microphone. Hopefully you can hear it. Pretty awful noise, but that's a piezoelectric speaker, and that's how it would sound. Now that one made that tone. Let's see if the other ones make a different tone. All right, so depending on which resistors we have connected, it changes the amount of electricity, the current running into the piezoelectric speaker, and that makes the noise different. So that was all based on resistance and the amount of electricity running into the piezoelectric speaker, depending on which button we're pressing. Because watch, and maybe they'll get into it. Let me see the next step first. All right, great. Congratulations, you learned how to add wires to power a piano circuit. Here are some pro tips. When a wire is selected, you can also cycle between wire colors by typing any number on your keyboard. For example, typing 0, remember that would be a 0 because they said number, will give you a black wire. You can also just click on it and then do a drop down. Okay? I'm guessing 0 will be the first one. Oops. Yep. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now that would be really good. I don't know what you do for 11, but that's a really good way, knowing those numbers if you're going to change a lot of wires at once. If you press the Shift key and then click on a button, the button will stay pressed. Clicking again on the button will release it. So I'm not going to do that because I don't want to annoy my family. That's a pretty bad sound. But it's pretty cool that it changes the notes. Breadboards are a powerful tool for prototyping with electronics. That's making something before it's permanent, coming up with ideas. If you're interested in learning more about using one, check out our tutorial on mastering the breadboard. Awesome. So let's go ahead and we'll move forward. Click continue, adding components. All right, in this tutorial, you'll learn to add components to make an interactive motor controller. Let's get started. So remember, when we do stuff on this simulator, if we did it in real life, it would work the same exact way. In the work plane, you'll find a motor connected directly to a battery pack. When we start the simulator, the motor will begin to rotate. So when I start that simulator, you'll see this is rotating, and it's telling us 5,902 revolutions per minute. That means if we had 3 volts directly connected to this motor, and it was connected, we would get 5,902 entire revolutions in 1 minute. So that's a pretty fast little motor running off of 3 volts. I say 3 volts because it's 2 AA batteries. Each AA battery is 1.5 volts. So we add those up and we get 3 volts. Now let's make our circuit interactive by adding a sensor. Sensors, I do have a video on sensors if you want to check that out. I'll link it. But there are things that can sense the world around us. Just like my sensors, my ears can sense sound. My taste buds can sense taste. My eyes can sense light. Electronics have sensors as well. So it says click plus components and search for a photoresistor. Now, honestly, I'm not sure what they're meaning by plus components, but if I scroll here, I could find it. Otherwise, I can type here. Maybe this is sort of outdated, or maybe I'm just missing something. But if I type photo, you'll see that it showed up right there. All right, click on the photoresistor and add it to your circuit below the red wire. Rotate the photoresistor by, okay, so I'm going to add it below the red wire. All right. Then it says rotate the photoresistor by clicking the rotate icon or pressing R on your keyboard. I'm going to use R because it's really important to learn a lot of the shortcuts. It saves a lot of time. So I'll press R, and now I can rotate it so that the pins are facing up. So I keep pressing R, it's facing up. Wonderful. Then it says delete the existing red wire by clicking on it. All right, and then press delete on your keyboard. Now you could press this little trash button too, but remember those shortcuts save you a lot. All right, wire the photoresistor so that one end is connected to the positive end of the battery, the other is connected to terminal 2. So if we click there, I would turn that to red just to keep it organized. Click there to there, turn that to red. Continue to the next step. Awesome. So let's move to the next step. Click the Start Simulation button. Okay, so this is the amount of light. The way a photoresistor works, and the really, really good example of this would be a night light with a little sensor. One of those night lights that turns on at night, turns off during the day when there's light. Maybe you've played with it. You put your hand in front of it, turns on, you move your hand, it turns off. Basically, it senses how much light is shining on it, and depending on how much light, it lets a certain amount of electricity through it. So it's not thinking, okay, this is just a component, a sensor, and what we're doing here is we're saying there's no light, a little bit of electricity is getting through. It's moving 2 revolutions per minute. And as we add more light, so this would be like shining a flashlight on it, it lets more electricity through, thereby getting this motor to move faster. And obviously, as we change it, now you'll notice this looks different. Sometimes they're trying to simulate what it would look like on a camera. You'll notice it was turning right. This is a lot like when we watch movies and we see car tires spinning and it looks like they're spinning backwards. That's just because of the refresh rate on cameras. So, but you'll notice ignore the direction that it seems to be spinning. It's always spinning to the right. You'll notice that the more light, the more electricity is being allowed through there, spinning the motor faster and faster. Remember, ignore the direction that it seems to be spinning. I know it looks like it's spinning to the left. I don't really like that they had done that, but that's okay. All right. It's an awesome simulator either way. You've now learned how to add components and integrate a sensor into your circuits. Great job. Continue tinkering. What happens to the speed of the motor when you adjust the number of AA batteries? Click on the AA battery to change the number of batteries in it. So what do you think will happen if I add more batteries? So if we added more batteries, what do you think would happen to the RPMs? You think they go up or they go down if we got more electricity? Now, I'm not sure how to do that, so I can actually... All right, so let's do this. I searched for batteries. I will add a battery. Maybe you'll figure out a way to add batteries. I'm not really seeing it. If I change that number, that's just the name. And if I right click on it, it doesn't do anything. All right, so this is continue tinkering. I'm not really sure how to add batteries, actually. I've played around with it a little bit. Maybe this is outdated, or maybe you'll figure out how to add it. There are different things down here, but we could do a 9-volt battery. We could definitely do that, because this is only putting out, we're putting out 3 volts. And if we connect these, you'll see it at high power, or at the most light that we can see if I run the simulator. At the most light, it's moving at 658 RPM. If I get rid of that and put a 9-volt battery in there, and remember we press R to rotate it, if I put that 9-volt battery in instead, and I guess we'll just leave it over there, run that to the positive, run this to the negative, we'll see if it runs, what was it, 658? Now it's running at 1,973. So as we add voltage, it makes it go faster because there's more electricity to let it spin. So let's click done. It says lesson completed. You've completed this lesson. Congratulations. So it looks like we're all done with this lesson. The next one will be a little bit more in depth. These were just the starters to learn how the interface works. Keep an eye out for new videos from me going through those next lessons. Have a wonderful day. Thanks for checking out STEM with Mr. Duda. Please like this video and subscribe. You can also set the bell to notify you when I make new videos. That really motivates me to continue posting these things online and gets you content that you're interested in. A lot of times I will link a playlist. Maybe one just showed up here. I might also link a video. It might show up right about here. And sometimes YouTube decides what video is best for you, but sometimes I assign one. So thank you so much for checking me out, and have a great day, everybody.